Imagine standing on a distant peak, gazing up at a night sky so vast it seems to stretch into eternity. Each twinkling star is a beacon of light, a reminder of the universe's grandeur and complexity. This ethereal scene is just a glimpse of the cosmic tapestry that envelopes us, an intricate web of galaxies, dark matter, and extraordinary phenomena that shape the very fabric of existence. At the heart of this cosmic web lies a vast interconnected structure, where billions of galaxies drift and dance in an endless ballet. Each galaxy, like our own Milky Way, is a colossal island of stars, gas, dust, and dark matter, intricately woven into the vastness of space. But what binds these galaxies together? The answer lies in the invisible threads of dark matter, a mysterious substance that constitutes about 27% of the universe's total mass energy. While we cannot see dark matter directly, its presence is felt in the gravitational effects it exerts on the visible matter around it. It is as if the universe whispers secrets through the cosmos, creating a delicate balance between attraction and repulsion. As we explore this grand cosmic web, we begin to see how galaxies cluster and form networks, revealing a structure that resembles a spider's web. In the heart of these clusters, we find immense superclusters, immense gravitational wells that shape the universe at the largest scales. Between these clusters lies vast voids, stretching for hundreds of millions of light-years, where the density of matter is astonishingly low. It is in these empty expanses that the mysteries of dark energy and the fate of the universe unfold. The journey through the cosmic web is not just a tale of cold, distant objects, it is a story of creation and evolution. The universe, born from a singular event known as the Big Bang, has been expanding ever since, carrying with it the seeds of galaxies and stars. Over billions of years, matter has clumped together under the influence of gravity, forming stars that ignite in brilliant explosions, giving birth to new worlds. This process is ongoing, a cosmic cycle of birth, life, and death that enriches the universe with complexity. As we delve deeper into the cosmic tapestry, we are compelled to confront the questions that define our existence. Where did we come from? Are we alone in the universe? Each discovery ignites a flame of curiosity, pushing the boundaries of our understanding. The universe is not a static backdrop, it is a dynamic, ever-evolving entity that holds countless secrets waiting to be unveiled. To navigate this vast cosmos, scientists employ a variety of tools. Telescopes, like the Hubble Space Telescope, allow us to peer into the depths of space, capturing images that reveal galaxies billions of light-years away. These snapshots of the universe's past offer insights into its evolution, showing us the beauty and diversity of celestial phenomena. Meanwhile, particle accelerators on Earth probe the fundamental forces that govern matter, helping us understand the building blocks of the universe. Each advancement in technology is a step closer to unraveling the mysteries woven into the cosmic fabric. Yet, the vast distances and timescales of the universe pose significant challenges. When we talk about the cosmic web, we are not just discussing the connections between galaxies, but also the immense distances that separate them. Light from the Andromeda Galaxy, our nearest galactic neighbor, takes over 2 million years to reach us. This means that when we gaze at Andromeda, we are observing it as it was 2 million years ago, a snapshot of a distant past. The universe is a historical record, and our understanding of it hinges on interpreting these ancient signals. Understanding the cosmic web is also essential for grasping the role of dark matter and dark energy, two of the universe's greatest enigmas. Dark matter, as we have seen, is responsible for the gravitational scaffolding that holds galaxies together, while dark energy drives the accelerated expansion of the universe. Together, they form the backbone of cosmic structure, influencing the trajectory of galaxies and the fate of the universe itself. As we unravel these mysteries, we gain a clearer picture of how the universe has evolved and how it might continue to change in the future. In this grand tapestry of cosmic wonders, we are not mere spectators, we are participants in a remarkable journey. Our planet, nestled within the Milky Way, is a testament to the intricate processes that have unfolded over billions of years. Each moment we explore the universe deepens our connection to it, reminding us that we are part of something much larger than ourselves. As we continue our exploration, let us embrace the wonder of the cosmos. The vastness of the universe invites us to look beyond our immediate surroundings, to ponder the mysteries of existence, and to dream of what lies ahead. With every discovery, we are not just unraveling the threads of the cosmic web, we are weaving together our understanding of the universe, inching closer to the answers that await us in the great unknown. As we venture further into this cosmic tapestry, we encounter a phenomenon that exists all around us yet remains elusive and largely invisible: dark matter. This enigmatic substance constitutes about 27% of the universe, shaping the very fabric of reality while remaining hidden from our senses. Imagine wandering through a vast forest, surrounded by tall trees, and yet, the ground beneath you is teeming with life, supporting the whole ecosystem, even though you cannot see it. Such is the role of dark matter in the universe. Dark matter does not emit, absorb, or reflect light, making it imperceptible to our optical instruments. Yet, its presence is felt through the gravitational influence it exerts on visible matter. Consider the swirling arms of galaxies, their stars and gas clouds moving in intricate patterns. The observed motion of these celestial bodies indicates that they are bound together by a gravitational force far more powerful than what we can account for using just the matter we can see. Dark matter acts as an unseen hand, holding galaxies together, preventing them from flying apart as they rotate. This invisible mass creates a framework that shapes the universe's structure, influencing the formation of galaxies, clusters, and even the vast cosmic voids that separate them. To grasp the significance of dark matter, we can look to the work of early 20th century astronomers like Fritz Zwicky. By studying the Coma cluster, Zwicky noted that the visible mass of the galaxies was insufficient to account for their observed motion. He proposed the existence of a substantial amount of unseen mass, coining the term dark matter. This idea, once thought radical, has since transformed our understanding of the cosmos. Recent studies, including precise measurements from the Hubble Space Telescope and the cosmic background radiation, have only solidified the notion that dark matter is a fundamental component of our universe. The quest to understand dark matter has led scientists to propose various candidates for its identity. One leading theory suggests that dark matter is composed of weakly interacting massive particles, or WIMPs. These hypothetical particles would interact with regular matter through gravity and possibly the weak nuclear force, yet remain undetectable through electromagnetic interactions. Imagine trying to catch a whisper in a thunderstorm. This is the challenge that physicists face in detecting these elusive particles. Further complicating our understanding is the intricate relationship between dark matter and dark energy, another mysterious component of the universe. Dark energy, which makes up approximately 68% of the universe, is responsible for the accelerating expansion of space. While dark matter works to pull structures together through its gravitational allure, dark energy pushes them apart, creating a dynamic interplay that shapes the universe's evolution. It's a cosmic ballet, with dark matter and dark energy performing their roles to choreograph the vast dance of existence. Delving deeper into this cosmic void, we can also explore how dark matter influences the large-scale structure of the universe. Galaxies do not form in isolation, rather, they exist in a vast network interconnected by filaments of dark matter that thread through the cosmos. These filaments create a web-like structure, with galaxies clustering around dense regions of dark matter in a phenomenon often referred to as the cosmic web. This framework not only provides the scaffolding for galaxy formation but also holds clues to the universe's fate. Recent simulations have revealed that the formation and growth of galaxies are guided by this dark matter web, which acts like a cosmic map, directing the flow of matter across vast distances. As galaxies collide and merge, they share their stars and gas, further enriching the universe's diversity. Understanding how dark matter influences these interactions can provide insights into the underlying mechanics of cosmic evolution, painting a clearer picture of the forces at play beyond what we can directly observe. As we turn our gaze back to the night sky, we are reminded that our observations are limited to a tiny fraction of the universe's total mass and energy content. The stars dotting the darkness are but a whisper of the vastness that lies beyond, echoing the influence of something greater that governs the cosmos. Our understanding of dark matter opens the door to questions that challenge our perceptions of reality. What does it mean to exist in a universe dominated by an unseen force? How does our knowledge of dark matter reshape our understanding of the laws of physics, and what can we learn about our place within this cosmic drama? The mysteries of dark matter invite us to rethink the boundaries of exploration and understanding. As we develop new technologies and refine our instruments, we edge closer to unraveling these cosmic enigmas. The next generation of particle physics experiments, like those conducted at the Large Hadron Collider, and advanced astronomical surveys promise to shed light on the nature of dark matter. The more we learn, the more we realize that the universe is a tapestry woven with threads of mystery, inviting us to venture into the void and discover the unseen forces that shape our existence. In this quest, we are reminded that while we may not see dark matter directly, its effects are all around us, guiding our journey through the cosmos. Each new piece of evidence, each refined model brings us one step closer to understanding this invisible architect of the universe. As we continue to explore the depths of space and the intricacies of dark matter, we also prepare to confront the profound questions that arise from our discoveries, forging a path toward a future rich with the potential for new insights and cosmic exploration. As we peer deeper into the cosmos, we encounter a breathtaking dance and elegant choreography played out among galaxies. These vast collections of stars, gas, dust, and dark matter are not just lonely islands adrift in the cosmic sea. They are dynamic entities, shaped by the gravitational forces that govern their existence, and driven by the mysterious presence of dark matter. Each galaxy is a testament to the intricate balance of forces that swirl through the universe, sculpting them over billions of years. Galaxies come in many forms, from spirals with their sweeping arms filled with brilliant stars and nebulae to the majestic elliptical galaxies that appear as glowing elliptical halos. Irregular galaxies, with their chaotic shapes, add to the diversity. But behind this variety lies a common thread: dark matter. This elusive substance makes up about 27% of the universe, yet its nature is still one of the greatest puzzles in modern astrophysics. The gravitational influence of dark matter is essential for forming galaxies and influencing their evolutionary paths. To understand how dark matter shapes these cosmic structures, we must first look at the moments just after the Big Bang. In those early days, the universe was a hot, dense soup of energy and particles. As it began to cool, slight fluctuations in density emerged, leading to the formation of primordial gas clouds. These clouds, influenced by gravitational forces, began to collapse, birthing the first stars and galaxies. However, it wasn't just the visible matter that played a role in this process. The gravitational pull of dark matter, which clumped together in vast halos, provided the scaffolding necessary for galaxies to form. These dark matter halos are vast and invisible, stretching far beyond the visible edges of galaxies. They not only influence how galaxies are shaped but also determine how they interact with one another. Within this cosmic web, galaxies are pulled together, forming clusters and superclusters, often merging into larger structures. The interplay of gravity between dark matter and visible matter governs the movement and behavior of galaxies in ways that are both profound and awe-inspiring. As galaxies dance through the universe, their interactions are marked by gravitational encounters that can lead to dramatic transformations. When two galaxies collide, for instance, it isn't just the stars within them that interact. The dark matter halos play a crucial role in this cosmic ballet. They can affect the trajectories of passing galaxies, guiding them into new paths. These mergers can trigger bursts of star formation as gas clouds collide, compress, and ignite, creating new stars and spectacular cosmic nurseries. Understanding the structure of galaxies also requires looking at their spiral arms, which are often rich in young stars. These arms are not static, they are waves of star formation sweeping through the galaxy. The presence of dark matter contributes to the stability of these structures. As stars orbit the center of their galaxies, the gravitational influence of dark matter ensures that the stars do not drift away, maintaining the integrity of the galactic form. Yet, beyond their striking beauty, galaxies are the very stars of the cosmic story, revealing the narrative of our universe's evolution. Observations have shown that galaxies are not uniformly distributed. Instead, they are part of a vast cosmic web, interconnected by filaments of dark matter. This web-like structure serves as a backbone for the universe, guiding the formation of galaxies and clusters. The more we investigate these patterns, the more we realize that dark matter is not just an unseen force, it is the architect of cosmic evolution. As we zoom out to view the universe as a whole, we begin to see the larger picture. Galaxies are not static entities but are ever evolving. They undergo a life cycle of birth, growth, and sometimes death. Some galaxies will consume others, merging in a graceful yet violent encounter, while others will be stripped of their outer regions by tidal forces from neighboring cosmic giants. These processes reveal a universe in constant motion, where galaxies are continually shaped and reshaped by the forces of gravity and dark matter. This cosmic dance raises profound questions about our place in the universe. As we study the formation and evolution of galaxies, we are drawn into the mystery of our own galaxy, the Milky Way. What influences have shaped its spiral arms, and how much dark matter exists in its halo? Answers to these questions not only illuminate the history of our home but also provide a window into the mechanisms that drive the evolution of galaxies across the universe. The quest to understand galaxies is not merely an academic pursuit, it is a journey that connects us to the cosmos. It invites us to ponder our own existence within this vast narrative. As we continue to observe and explore, we will refine our understanding of dark matter's role in galactic formation and evolution. Every discovery leads us to new questions, expanding our perspective and deepening our curiosity about what lies beyond the stars. In this celestial panorama, the dance of galaxies is a reminder of the beauty and complexity that permeates the universe. It serves as a testament to the unseen forces that shape our reality, urging us to continue our exploration of the cosmos. As we look toward the future, we gear up to confront the mysteries that await us, unveiling the secrets of dark matter and the intricate web of galaxies that together create the grand tapestry of existence. Gravity, that fundamental force we often take for granted, stands as the silent architect of the cosmos, orchestrating the grand ballet of celestial bodies across the vastness of space. It is a force that binds galaxies, shapes star clusters, and influences the very paths that stars and planets tread. Understanding gravity is essential to deciphering the movements we observe in the night sky, and it reveals the profound interconnectedness of the universe. Imagine a galaxy, a swirling mass of stars, gas, and dust, all dancing together in a magnificent display of harmony. Gravity acts as the conductor of this cosmic orchestra, pulling matter together, inviting the formation of stars and the birth of new worlds. Each star, in turn, exerts its own gravitational pull, creating a complex web of interactions that influence their neighbors. The interplay of these forces governs the orbits of planets, the trajectories of comets, and even the accretion of material around supermassive black holes at the centers of galaxies. As we peer deeper into the cosmos, we see that gravity is not just a local phenomenon, it operates on vast scales, shaping the universe itself. Galactic clusters, those colossal collections of galaxies, are held together by the gravitational attraction of their members. In these rich environments, we witness the effects of gravity magnified, where the distances between galaxies can stretch across millions of light-years, and yet they remain bound in a cosmic dance. The gravity of each galaxy influences the motion of others, creating intricate patterns that tell a story of formation, evolution, and, ultimately, the fate of the universe. Yet gravity is more than just a force, it is a messenger of the universe's fabric. The theory of general relativity, proposed by Albert Einstein over a century ago, transformed our understanding of gravity from a simple attraction to an intricate curving of spacetime itself. Mass and energy warp the very structure of spacetime, causing objects to follow paths dictated by this curvature. This means that when we observe the movements of stars and galaxies, we are witnessing not just gravitational attraction, but the elegant dance of spacetime itself. Consider the journey of light as it travels through this warped spacetime. When light passes near a massive object, like a star or a galaxy, it bends, creating the phenomenon known as gravitational lensing. This effect allows astronomers to observe distant objects that might otherwise remain hidden from our view, amplifying our understanding of the universe. Through gravitational lensing, we can uncover the presence of dark matter, the invisible substance that permeates the cosmos, exerting its influence through gravity alone. Gravity also plays a pivotal role in the life cycles of stars. As they form from clouds of gas and dust, gravity pulls material inward, igniting nuclear fusion in their cores. This process creates energy that counteracts gravity's pull, establishing a delicate balance that governs a star's longevity. Over millions, even billions of years, stars evolve, expand, and ultimately meet their fates, some becoming red giants, while others collapse into white dwarfs, neutron stars, or even black holes. Each of these endpoints contributes to the cosmic cycle, reintegrating material into the universe to birth new generations of stars. In the grander scheme, the distribution of matter across the universe is a reflection of gravitational forces at play. The cosmic web, a vast network of galaxies and dark matter, reveals the structure of the universe on the largest scales. This web consists of filaments where galaxies cluster, separated by vast voids of empty space. Gravity draws galaxies along these filaments, and in turn, the distribution of galaxies helps scientists map the underlying dark matter that shapes the universe's architecture. It is a stunning interplay between the seen and the unseen, offering glimpses into the cosmic forces that govern our reality. As we contemplate the future of interstellar travel and our quest for understanding, gravity remains a crucial consideration. To traverse the vast distances between stars, we must unlock the secrets of propulsion, harnessing the very forces that govern motion in the cosmos. Imagine a future where humanity has learned to navigate the fabric of spacetime, allowing us to leap across the vast expanses of the universe with newfound ease. Advances in technology may one day enable us to manipulate gravity, creating pathways through space that defy our current understanding. But the journey into the unknown is fraught with challenges. The immense gravitational pulls of massive celestial bodies can create dangerous barriers for any spacecraft venturing too close. Understanding these dynamics is vital to ensuring safe passage through the cosmic landscape. As we prepare for future exploration, we must remain acutely aware of gravity's influence, respecting the delicate balance that exists within our universe. In essence, gravity is both a force and a teacher, guiding our understanding of the cosmos and paving the way for our exploration of the stars. It confronts us with questions about our place in the universe and inspires us to seek answers among the stars. As we continue our journey through the cosmic web, we find ourselves at the intersection of science and wonder, drawn into the depths of the unknown by the silent hand of gravity, ever eager to reveal the mysteries that lie ahead. As we delve deeper into the cosmic fabric, we inevitably encounter one of the most enigmatic and fascinating phenomena in the universe: black holes. Formed from the remnants of massive stars that have exhausted their nuclear fuel, these celestial giants hold secrets that challenge our very understanding of the laws of physics. A black hole is not just a void in space, it is a region where gravity exerts such a powerful pull that nothing, not even light, can escape its grasp. This unique characteristic gives rise to their name, invoking images of darkness and mystery. The life cycle of a black hole begins with the explosive death of a massive star in a supernova event. At the heart of this explosion, the core collapses under its own weight, compressing matter into an infinitesimal point known as a singularity. Surrounding this singularity is the event horizon, a boundary that marks the point of no return. Once crossed, any matter or radiation is inexorably pulled into the black hole, rendering it invisible to the outside universe. This stark transition from a luminous star to a dark abyss is a profound transformation, one that highlights the extreme conditions that govern the universe. Black holes come in various sizes, from stellar black holes, which are a few times the mass of our Sun, to supermassive black holes that dwell at the centers of galaxies, containing millions to billions of solar masses. These supermassive giants play a critical role in the evolution of galaxies, influencing their formation and behavior. The dynamics of stars and gas swirling around a black hole create a mesmerizing dance, illuminating the cosmic ballet that unfolds in the depths of space. Yet, despite their massive presence, black holes remain elusive. They do not emit light, nor do they reflect it, making them difficult to detect directly. Instead, we observe their effects on nearby objects. When a star ventures too close to a black hole, it may be torn apart by the immense tidal forces, a phenomenon known as spaghettification, where matter is elongated and distorted as it approaches the event horizon. This process releases energy, allowing us to detect the black hole indirectly through the brilliant X-ray emissions produced during the violent interaction. The nature of black holes raises profound questions about the fabric of reality itself. They challenge our comprehension of space and time, as they warp the very dimensions we rely on to describe the universe. According to Einstein's theory of general relativity, massive objects create curvature in spacetime, and black holes represent an extreme case of this effect. Near a black hole, time behaves differently. Time slows down dramatically for an observer as they approach the event horizon compared to someone far away. This curious distortion leads to fascinating implications for the nature of time and its passage in the universe, suggesting that our perception of reality may be far more complex than we can imagine. Furthermore, black holes are not static entities, they can grow and evolve. When they collide with other black holes or draw in gas and stars from their environment, they can gain mass and spin. This growth is accompanied by the release of tremendous amounts of energy, visible as powerful jets of particles that shoot out into space at nearly the speed of light. These jets are not only awe-inspiring but also serve as beacons of cosmic activity, allowing astronomers to study the behavior of black holes and their surrounding environments. As we strive to understand the mysteries surrounding black holes, we find ourselves confronting the limits of current physics. One of the most pressing issues is the problem of singularities, points of infinite density where the laws of physics as we know them break down. This conundrum leads us to question the very foundations of our scientific understanding. How can we reconcile the principles of quantum mechanics, which govern the behavior of subatomic particles, with the predictions of general relativity in the presence of a black hole? The quest for a unified theory that encompasses both realms remains one of the greatest challenges in modern physics. In the pursuit of knowledge, researchers are exploring radical ideas that may offer clues to the nature of black holes. Concepts such as Hawking radiation, proposed by the physicist Stephen Hawking, suggest that black holes can emit radiation and potentially evaporate over time. This groundbreaking theory implies that black holes are not entirely black, but instead, they may leak energy back into the universe, leading to a fascinating interplay between destruction and creation. As we stand at the edge of understanding, black holes serve as a reminder of the vastness of our ignorance and the depth of cosmic mysteries yet to be unraveled. They are not merely cosmic vacuum cleaners, but rather gateways to fundamental questions about existence, reality, and the nature of the universe itself. Each discovery about black holes brings us closer to unveiling the hidden tapestry of the cosmos, calling to our innate curiosity and wonder. In this intricate web of dark matter and gravitational forces, black holes challenge us to think beyond traditional boundaries, urging us to explore the unseen dimensions of our reality. As we continue our cosmic journey, navigating the profound implications of black holes, we are reminded that every answer often leads to new questions, propelling us forward into the unknown, expanding our understanding of the universe and our place within it. As we delve deeper into the enigmatic realm of black holes, we encounter two concepts that lie at the very heart of their mystery: singularities and event horizons. These phenomena not only challenge our comprehension of physical laws but also stretch the limits of our imagination, forcing us to grapple with paradoxes that seem to defy reason. At the core of a black hole lies the singularity, a point where gravity exerts an infinite pull, collapsing all matter and energy into an infinitely dense state. In this region, the fabric of spacetime becomes warped to such an extent that the known laws of physics break down. Here, concepts like time and space lose their conventional meaning. Imagine looking into the abyss of a black hole and realizing that you are witnessing a place where the rules that govern our universe cease to function. It is a phenomenon that raises profound questions. What happens to the laws of physics when we reach this extreme? How can we even begin to conceptualize a point where density and gravitational force become limitless? Surrounding the singularity is the event horizon, an invisible boundary that defines the point of no return. Once crossed, even light cannot escape the gravitational grip of the black hole, making it impossible for any information to escape back into the universe. The event horizon serves as a cosmic threshold, a one-way gate into the depths of darkness. From our vantage point in space, anything that crosses this barrier is effectively lost to us, swallowed by the black hole's insatiable hunger. The irony is that while we can observe the effects of black holes on surrounding matter, the interior remains shrouded in mystery, forever out of reach. This interplay between the singularity and the event horizon brings forth a tantalizing paradox. If information is lost to the universe once it crosses the event horizon, does this mean that the very fabric of reality is being altered? The implications are staggering. The preservation of information is a cornerstone of quantum mechanics, yet black holes seem to pose a direct challenge to this principle. Can something truly vanish into the void, or is there a possibility that information is somehow preserved, concealed within the black hole's depths? Many physicists have grappled with this question, leading to the formulation of the holographic principle. This theory suggests that all the information contained in a volume of space can be represented as a two-dimensional hologram on its boundary. In the case of black holes, this means that the information swallowed by the event horizon might not be lost but rather encoded on its surface. If true, this revolutionary idea could bring harmony between quantum mechanics and general relativity, two pillars of modern physics that often seem incompatible. Exploring this cosmic conundrum doesn't just illuminate the nature of black holes but also invites us to reflect on our understanding of reality itself. It beckons us to question the very nature of existence and the boundaries of knowledge. As we stand on the precipice of these mysteries, we find ourselves in a space filled with infinite possibilities and questions that may never find definitive answers. The influence of supermassive black holes further complicates our understanding of singularities and event horizons. These colossal entities lie at the center of most galaxies, including our own Milky Way, serving as the gravitational anchors around which stars and gas clouds orbit. Their immense gravitational forces shape the structure of galaxies and influence star formation, revealing a delicate interconnectedness in the cosmic web. Some theories suggest that supermassive black holes may play a critical role in the evolution of galaxies, highlighting how these enigmatic structures extend their reach far beyond their immediate vicinity. As we ponder the impact of black holes, we also find ourselves grappling with the implications for future technologies and our potential for interstellar exploration. The mysteries of singularities and event horizons could hold the key to unlocking new pathways through the cosmos. Concepts like wormholes, theoretical passages through spacetime, emerge from the equations of general relativity. If traversable wormholes could exist, they might serve as shortcuts through the fabric of spacetime, allowing us to bypass the vast distances that separate stars and galaxies. Yet, with great potential comes immense challenges. The stability of these hypothetical structures remains a topic of speculation, and the immense energy required to create or manipulate them is beyond our current technological reach. The physics of propulsion for spacecraft designed to navigate cosmic distances must also account for the peculiarities of black holes and their event horizons. How do we create vessels that can withstand the intense gravitational forces and navigate the uncertain waters of spacetime? As we grapple with these questions, the role of artificial intelligence becomes increasingly significant. AI could provide the computational power needed to model complex gravitational interactions and simulate the effects of traveling near a black hole. By harnessing the vast potential of these technologies, we may one day unveil the secrets hidden within singularities and event horizons, transforming our journey through space. The exploration of black holes serves as a reminder that the universe is filled with profound mysteries waiting to be unlocked. As we continue our quest for knowledge, we must remain open to the unexpected revelations that await us. Each discovery leads us deeper into the unknown, expanding our understanding of the cosmos and our place within it. With every question we answer, we are inevitably drawn to new inquiries, igniting our sense of wonder and curiosity, propelling us forward on this extraordinary journey through the universe. As we continue our exploration of the cosmos, we venture into the heart of galaxies where supermassive black holes reside. These colossal entities, often weighing millions or even billions of times more than our Sun, sit like invisible titans at the centers of galaxies, exerting a gravitational pull that shapes the very fabric of galactic dynamics. Their presence is more than just a curiosity, it plays a vital role in the evolution and structure of the universe itself. Supermassive black holes are not merely points of darkness, they are engines of cosmic activity. The gravitational influence they wield affects the motion of stars and gas clouds in their vicinity, dictating the orbits of stars that swirl around them at astonishing speeds. Imagine a bustling metropolis where every skyscraper is in constant motion, each dictated by the gravity of a central, unseen force. This is akin to how stars in a galaxy zip around the supermassive black hole, forming a complex dance that keeps the galaxy structured and vibrant. But how do these behemoths come to exist? The journey of a supermassive black hole likely begins with the collapse of massive stars, leading to stellar black holes. Over billions of years, these smaller black holes can merge and grow, consuming surrounding gas and stars as they do. This process is not isolated, it is interconnected with the galaxy's own growth, influencing star formation and the distribution of matter. In fact, the more scientists look, the more they find that nearly every large galaxy harbors a supermassive black hole at its core. This correlation between galaxies and their black holes suggests a profound relationship, perhaps hinting that the formation of galaxies and black holes evolved together. As we delve deeper into their influence, we begin to uncover the phenomenon known as active galactic nuclei. When supermassive black holes consume matter, they unleash torrents of energy, emitting radiation that can outshine entire galaxies. This fiery display not only illuminates the cosmos but also has implications for the surrounding galaxy. The energy released can trigger cosmic winds, sweeping through the galaxy and regulating star formation. In this way, supermassive black holes can act as cosmic gardeners, nurturing the very ecosystems of galaxies while simultaneously putting the brakes on unchecked growth. This dynamic between black holes and their host galaxies is intricate and multifaceted. Observations have revealed that the mass of a supermassive black hole correlates with the velocity of stars in the galaxy's bulge. The faster the stars move, the larger the black hole appears to be. This relationship suggests that the black hole doesn't just influence the galaxy, it may also act as a kind of regulatory mechanism, ensuring that the galaxy and its central black hole develop in tandem. It's a cosmic symbiosis, where the health of one directly impacts the other. Exploring the implications of this connection leads us to consider the fate of galaxies over cosmic time. As galaxies collide and merge, their central black holes often follow suit. When two galaxies spiral toward one another, their supermassive black holes are drawn together, eventually forming a binary black hole system. This not only triggers dramatic changes in the galaxies involved but also leads to gravitational waves that ripple through spacetime, detectable by our earthbound instruments. These cosmic events reveal the dynamic nature of the universe, a universe filled with collisions, mergers, and transformations. Yet, despite their immense power and influence, supermassive black holes remain enigmas. We are only beginning to understand their role in the broader cosmic narrative. Their formation mechanisms, growth patterns, and interactions with galaxies are still subjects of intense research. Each observation, each measurement, shines a light on the mystery shrouding these giants, prompting us to reconsider our models of cosmic evolution. The more we learn, the more we realize that these dark entities are not merely destructive forces, instead, they are integral to the cosmic tapestry, knitting together threads of matter and energy across vast distances. As we stand on the precipice of this knowledge, we are also reminded of the potential awaiting us as we harness advanced technologies like the next generation of space telescopes. These tools will allow us to gaze deeper into the universe than ever before, illuminating the shadows cast by supermassive black holes. With each breakthrough, we inch closer to deciphering their myriad secrets, piecing together the puzzle of their existence and their influence on the universe at large. The exploration of supermassive black holes is not just a study of the dark, it is a journey into the heart of understanding. It beckons us to ponder the nature of gravity itself, the life cycle of galaxies, and the very fabric of spacetime. As we contemplate the unseen forces that govern the cosmos, we are reminded of our own place within this grand structure, each of us a tiny fragment of a much larger whole, forever intertwined with the mysteries that lie beyond the stars. As we press on, fueled by our insatiable curiosity and the promise of new horizons, we embrace the challenges and wonders that await us. The universe, with all its complexities and contradictions, continues to unfold, inviting us to participate in this cosmic dance. With each discovery of supermassive black holes and their impact on galactic dynamics, we do not just learn more about the cosmos, we also expand our understanding of ourselves and the potential futures that lie ahead in this vast expanse. As we delve further into the mysteries of our universe, we encounter a concept that captures the imagination in ways few others can: wormholes. These theoretical bridges in spacetime tantalize scientists and dreamers alike, offering the tantalizing possibility of shortcuts through the cosmos. Imagine standing in one corner of the universe and, in the blink of an eye, finding yourself in a distant galaxy, light years away. The notion that such a phenomenon could exist challenges our understanding of physics and pushes the boundaries of what we consider possible. Wormholes arise from the equations of general relativity, a framework developed over a century ago by Albert Einstein. His revolutionary ideas transformed our grasp of space and time, suggesting that massive objects warp the fabric of the universe around them. Within this framework, wormholes are theorized to be tunnels connecting separate points in spacetime. They come in various forms, with the most famous being the Einstein-Rosen bridge, a structure that connects two black holes. Though their existence has yet to be proven, the mathematical descriptions suggest that they could allow for instantaneous travel between vast distances. Visualize a piece of paper folded in half, with two dots drawn on opposite ends. If you pierce a hole through the paper, connecting the two dots directly, you create a shortcut that defies traditional travel across the surface. This analogy gives us a glimpse into the potential of wormholes, where the shortest path between 2 points is no longer a straight line but a shortcut through the very fabric of spacetime itself. However, traversing these paths presents monumental challenges, both theoretical and practical. One of the greatest obstacles lies in the stability of wormholes. The equations governing their existence hint at the necessity of exotic matter, substances with negative energy density, to keep the bridges open. Without this exotic matter, a wormhole might collapse under its own weight, closing off the passage before anything could successfully navigate through. This exotic matter is purely theoretical. We have yet to observe it or understand how it might be harnessed. The search for these mysterious components pushes the boundaries of our understanding of physics, evoking a sense of cosmic curiosity. As we consider the implications of wormholes, we are compelled to ask deeper questions about the nature of our universe. If wormholes are indeed possible, do they offer a pathway not only across space but also through time? The prospect of time travel adds another layer of complexity to these cosmic shortcuts. Theoretical scenarios suggest that traversing a wormhole could allow us to leap into the past or future, posing profound questions about causality and the linear progression of time. This exploration of wormholes doesn't just ignite our imagination, it sets the stage for contemplating the potential for interstellar travel. Colonizing distant planets or visiting far-off stars might not remain confined to the realm of science fiction if we can unlock the secrets of these bridges in spacetime. Picture a future where humanity harnesses the power of wormholes to expand our reach across the galaxy, transforming us from a single-planet species to interstellar explorers. Yet, even if we could construct a stable wormhole, the challenges do not cease. The energy required to create or maintain a wormhole is staggering, far beyond our current technological capabilities. Navigating through these cosmic tunnels would also demand a level of precision and understanding of spacetime that we have yet to achieve. Theoretical physicists debate the various models and implications, but practical applications remain distant in our future. As we unravel the fabric of the universe, we also confront the ethical implications of such powerful technologies. The ability to traverse vast distances in an instant could change the dynamics of exploration and colonization. What responsibilities would we hold as we venture into the cosmic depths? How would this capability reshape our relationships with other potential life forms, or even with ourselves? The quest to explore wormholes invites not only scientific inquiry but also philosophical reflection on our role in the universe. In the cosmic web we inhabit, wormholes represent one of the myriad possibilities that spark our quest for understanding. They embody the intersection of our curiosity and our relentless pursuit of knowledge. These hypothetical structures remind us that the universe is not merely a collection of distant stars and galaxies but a dynamic, interconnected reality that challenges our perceptions of space, time, and existence itself. As we ponder the nature of wormholes, we are reminded of the profound mysteries that still lie ahead. The cosmos stands as a vast canvas, painted with the brushstrokes of time and space, inviting us to explore its depths. Each discovery, each new hypothesis, adds to the intricate tapestry of our understanding, revealing layers of complexity that inspire awe and wonder. The journey through this cosmic landscape is far from over. Wormholes, with their promise of shortcuts through the universe, compel us to look beyond the horizon of our current knowledge and dream of the possibilities that await. As we venture forth, we may find that what we once deemed impossible could very well be within our grasp if only we continue to seek, to question, and to explore. Each step into the unknown brings us closer to unraveling the mysteries of our universe and perhaps of our own existence within it. As we look beyond our solar system, the vastness of space can feel overwhelming. The stars that twinkle in our night sky are not just points of light, they are gateways to realms of possibility. Yet, the distances that separate us from these celestial bodies are staggering. Even the closest star system, Alpha Centauri, lies over 4 light-years away, a journey that would take our fastest spacecraft thousands of years to complete. This realization ignites a question that has captivated the human imagination for generations. How can we traverse the cosmos, reaching distant worlds in a timeframe that aligns with our lives and ambitions? What if we could travel faster than light? The idea of faster-than-light travel is not merely the stuff of science fiction. It sparks an exploration of scientific theories and speculative technologies that may one day make it a reality. One of the most intriguing concepts arises from Einstein's theory of relativity, which tells us that as we approach the speed of light, our mass effectively becomes infinite, making it impossible for anything with mass to surpass that cosmic speed limit. However, physicists have pondered whether we might bend the fabric of spacetime itself rather than surpassing this barrier in a traditional sense. One such theory is the concept of warp drives, which was popularized by science fiction but has roots in serious scientific inquiry. The theoretical framework for a warp drive was first proposed by physicist Miguel Alcubierre in 1994. He envisioned a spacecraft that would contract space in front of it while expanding space behind it, creating a warp bubble that allows the craft to move across vast distances at effective speeds greater than light without violating the laws of physics. Imagine sailing smoothly along a wave in an ocean, where the water itself is manipulating around you. However, the challenges remain daunting. The energy requirements for such a warp bubble are theorized to be astronomical, possibly requiring exotic matter with negative energy density, materials that we have yet to discover or understand fully. And even if we could harness the energy, there are profound questions about the stability of such a warp bubble and the effects it might have on objects within its vicinity. Another theoretical pathway involves wormholes, those enigmatic tunnels through spacetime. If they exist, they could theoretically connect two distant points in the universe, allowing for instantaneous travel like a cosmic shortcut. However, like warp drives, traversable wormholes remain speculative. They raise a host of questions about their formation, stability, and the exotic materials required to keep them open. The very nature of these wormholes seems to dance on the edge of our current understanding of physics, challenging us to think beyond the ordinary. Yet, these concepts, while fascinating, are still firmly anchored in the realm of theory. Our pursuit of practical interstellar travel demands a closer look at propulsion technologies that can push the boundaries of our current spacecraft. One promising avenue of research is ion propulsion, which uses electric fields to accelerate ions, providing a highly efficient means of propulsion over long distances. Though ion drives already power some missions, like NASA's Dawn spacecraft, they operate at relatively low thrust and are not yet capable of achieving the high speeds needed for interstellar journeys. Then there's the concept of nuclear propulsion. By harnessing the immense energy released during nuclear reactions, spacecraft could achieve greater velocities than conventional chemical rockets. Theoretical designs, such as the Project Orion and Project Daedalus, have explored using nuclear fusion reactions as a propulsion method, potentially allowing us to reach neighboring star systems within a human lifetime. However, these concepts face significant engineering and safety hurdles that must be addressed before they can transition from the drawing board to the stars. As we work to develop these technologies, we must also confront the challenge of the vast distances involved. The closest exoplanets, many of which could be candidates for hosting life, are light years away. The challenge of reaching them in a reasonable timeframe requires us to think not just of propulsion but also of life support systems that can sustain human crews over extended periods. Innovations in closed-loop systems, resource recycling, and possibly even artificial gravity could become essential as we consider the realities of long-duration space travel. However, the quest for interstellar travel is not just about engineering, it challenges our ethical frameworks as well. As we embark on an exploration of the cosmos, questions arise about our responsibilities to other potential life forms we may encounter and the implications of colonizing new worlds. Should we take our problems to new planets, or should we first seek to solve them here on Earth? These considerations must accompany our technological advancements as we forge ahead into the unknown. Ultimately, the pursuit of faster-than-light travel remains a beacon of hope, a testament to human ingenuity and our unyielding desire to explore. While we may still stand at the threshold of this cosmic frontier, the theories and technologies we are developing today could one day allow us to explore the far reaches of the universe. With each discovery, we not only expand our understanding of spacetime but also redefine what it means to be a part of this vast, interconnected cosmic tapestry. As we look to the stars, let us remember that the journey of exploration, both outward and inward, is just as important as our destination. As we set our sights on the stars, the mechanics of propulsion become a vital part of our interstellar ambitions. The challenges of moving through the cold void of space require ingenuity and a deep understanding of physics. Traditional chemical rockets, while effective for reaching orbit, reveal their limitations when considering the vast distances that separate us from other celestial bodies. To traverse these immense cosmic distances, we must explore advanced propulsion technologies that promise to transform our capabilities. One of the promising concepts in this arena is nuclear thermal propulsion. Imagine harnessing the power of nuclear reactions to produce thrust. In a nuclear thermal engine, a nuclear reactor heats a propellant, typically hydrogen, which then expands rapidly and is expelled out of the spacecraft. This method offers an impressive increase in efficiency compared to conventional rocket fuels. The energy density of nuclear fuel is astronomical. A small amount can produce an immense amount of heat, allowing spacecraft to achieve higher speeds and carry larger payloads. This could mean faster journeys to Mars, asteroids, or even the outer planets of our solar system, vastly reducing travel time and enabling more ambitious missions. Transitioning further into the realm of advanced propulsion, we encounter ion drives. Unlike their chemical counterparts, ion thrusters work by ionizing a propellant and using electric fields to accelerate these charged particles. This innovative method allows for a continuous and efficient thrust over long periods. The efficiency of ion drives is measured in specific impulse, a term that indicates how effectively a propulsion system converts fuel into thrust. While they produce a relatively small amount of thrust, the sustained nature of ion propulsion means that a spacecraft can gradually build up to significant speeds over time, making them ideal for deep space missions where long-duration travel is essential. The beauty of ion drives lies in their ability to operate with minimal amounts of fuel. They are already being employed in missions such as NASA's Dawn spacecraft, which explored the asteroid belt and provided invaluable insights into the early solar system. The technology is a harbinger of what might be possible as we look toward the more distant stars. Imagine a future where these propulsion systems enable us to send probes to the nearest star systems within a human lifetime, unlocking the secrets of worlds beyond our own. However, as we dream of reaching other solar systems, we must also confront the challenges of propulsion under various conditions. The physics of propulsion is not just about thrust, it's about the journey through a diverse and often hostile environment. Space is a vacuum, devoid of the atmospheric drag and friction that we experience on Earth. This absence of air enables spacecraft to coast through the cosmos, but it also demands precision in navigation and control. Any miscalculation can lead to significant deviations from a planned trajectory, especially over the vast distances involved in interstellar travel. The concept of propulsion also expands into theoretical domains where the boundaries of our understanding of physics are tested. The idea of electromagnetic propulsion, for instance, suggests the possibility of using magnetic or electric fields to propel a spacecraft. Theoretical concepts like the M-drive have stirred interest and debate within the scientific community, although practical applications remain elusive. These innovative ideas could redefine our approach to space travel, potentially allowing for rapid movements across the galaxy. As we continue to explore these advanced propulsion technologies, we also need to consider the implications of our discoveries. The potential for faster-than-light travel, while currently grounded in theoretical physics, raises profound questions about the nature of spacetime and causality. Concepts such as warp drives, which propose bending spacetime itself to achieve faster-than-light speeds, ignite the imagination and push the boundaries of what we know. Should we unlock such capabilities, we would not merely be travelers of the cosmos, we would become a part of its very fabric. Yet, while we explore these possibilities, we must remain grounded in the ethics of our exploration. As we develop advanced technologies, we must consider the impact of our actions on the universe around us. The unknowns of cosmic exploration demand a responsible approach, ensuring that our quest for knowledge does not come at the expense of celestial bodies or potential ecosystems we may encounter. The development of propulsion systems is not merely a technical challenge, it is a step toward becoming stewards of the cosmos. Each innovation brings us closer not only to new worlds but also to understanding our own place in the universe. With advanced propulsion methods at our disposal, the dream of reaching other stars becomes more tangible, allowing us to envision a future where humanity is not limited to Earth but is an active participant in the cosmic ballet. As we refine these technologies and continue to probe the mysteries of the universe, the potential for interstellar travel looms ever larger on the horizon. The physics of propulsion is not just a means to an end, it is a bridge to new realms of possibility. With every leap in our understanding, we unlock new pathways that connect us to the stars, transforming aspiration into reality. Our journey into the cosmos is an unending exploration of the known and unknown, creating a legacy that extends beyond our lifetimes and shapes the destiny of future generations. As we turn our gaze toward the stars, we confront a staggering reality: the distances that separate us from other worlds are not merely vast, they are mind-bending. The nearest star system to our own, Alpha Centauri, lies over 4 light-years away. To put that into perspective, if we were to travel at the speed of light, it would take just over 4 years to reach it. But our current spacecraft travel at a fraction of that speed, making such a journey a monumental challenge. The vast emptiness of space is not just a backdrop, it is an obstacle, a cosmic desert that tests our ambitions and ingenuity. Imagine standing on Earth and gazing up at the night sky, a glittering expanse filled with countless stars. Each point of light represents an entire solar system, some potentially harboring life. Yet, between us and these distant worlds lies a chasm of light years. This realization ignites a deep sense of wonder, but it also leads us to ponder the implications for human exploration beyond our solar system. How do we bridge these seemingly insurmountable gaps? The concept of cosmic distances challenges our traditional notions of travel. On Earth, we measure distances in miles or kilometers, and the journey from one place to another can often be completed in hours. But in space, those measurements transform into staggering numbers. Our own solar system, a mere neighborhood in the vast cosmic city, spans light minutes. The outer reaches of our solar system, where the cold and dark reign, are still just a fraction of the scale of the Milky Way galaxy, which is about 100,000 light-years across. This scale stretches our imagination and reshapes our understanding of what it means to explore. In considering the vastness of space, we are reminded that human beings have always been explorers. From the early navigators who sailed uncharted waters to the pioneers of aviation, our quest to discover what lies beyond the horizon has driven us forward. Yet, as our aspirations soar into the cosmos, we find ourselves grappling with questions that challenge our very essence. How do we reach stars that are so far away? How do we sustain ourselves across the gulf of interstellar space? Current propulsion technologies are insufficient for such a journey. The fastest spacecraft we have ever built, traveling at nearly 40,000 kilometers per hour, would take around 70,000 years to reach Alpha Centauri. This stark reality compels us to think beyond conventional methods. Future technologies must not only increase our speed but also address the fundamental challenges of life support, radiation exposure, and the psychological impacts of long-duration space travel. The exploration of cosmic distances also raises profound questions about time. Light from distant stars takes thousands or millions of years to reach us. When we observe a distant galaxy, we are seeing it as it was eons ago, not as it is in the present. This disconnect between observation and reality adds layers of complexity to our exploration. If we were to send a probe to a distant star, it would likely arrive long after we have left our home planet and perhaps long after humanity has changed or evolved. This notion evokes a sense of urgency in our quest. The cosmic clock is ticking, and our window of opportunity to explore and understand these distant realms is finite. The challenge of cosmic distances is not just a question of physics, it is a question of human endeavor, spirit, and survival. As we aim for the stars, we must also confront the realities of our existence on Earth. The resources we will need for long voyages must be developed and sustainably managed. Simultaneously, we must not overlook the potential for discovery right within our own solar system. As we look outward, we also look inward, seeking to understand the myriad worlds that share our Sun. Moons like Europa and Enceladus may harbor subsurface oceans, and Mars holds clues about the very origins of life. Before we can reach for the stars, we must first lay the groundwork right here at home. The potential for new propulsion technologies, such as ion drives or theoretical concepts like antimatter engines, sparks excitement and hope. These advancements could one day decrease travel times to a scale we can comprehend. Researchers are also exploring the intricacies of warp drives and wormholes, fantastical ideas that could bend or warp spacetime itself, possibly allowing us to traverse distances that would otherwise take light years in mere moments. As we delve into these ambitious concepts, we confront another layer of challenge: the need for international collaboration. The journey into the cosmos is not one that a single nation can undertake alone. The vastness of space requires us to come together, pooling our resources, knowledge, and creativity to navigate these distances. By fostering a spirit of cooperation, we can share the burden of exploration and, in turn, share the rewards that come from understanding our universe. In this grand endeavor, the challenge of cosmic distances serves as a reminder of our place in the universe. We are but a small part of a vast and intricate tapestry woven from the fabric of stars, galaxies, and cosmic phenomena. Each step we take, each breakthrough we achieve, propels us closer to bridging the great void, transforming dreams of interstellar travel into tangible realities. As we strive to conquer the distances that separate us from our celestial neighbors, we carry with us the hope of discovery and the promise of a future intertwined with the cosmos. As we turn our gaze outward, we find ourselves amidst the vast expanse of the universe, where the search for exoplanets unfolds like a grand adventure. These distant worlds, orbiting stars beyond our solar system, have captivated our imaginations and sparked our curiosity about life beyond Earth. With advancements in technology and observational techniques, humanity has begun to unravel the intricacies of this cosmic search, revealing a tapestry of planets that may harbor the conditions necessary for life. The first confirmed exoplanet was discovered in 1992, orbiting a pulsar, forever changing our understanding of planetary systems. Since then, the pace of discovery has surged, thanks in part to missions like Kepler and TESS, which have scoured the skies for subtle dips in starlight, a telling sign that a planet is crossing in front of its host star. Each detection brings with it a sense of excitement and awe, as we uncover worlds that range from familiar rocky terrains to gas giants that dwarf Jupiter. In this cosmic sea, we are beginning to discern patterns and characteristics that could indicate the potential for life. To qualify as a habitable world, a planet must exist in what is termed the Goldilocks zone, a region around a star where conditions are just right, not too hot and not too cold, for liquid water to exist. Water, as we know, is a fundamental ingredient for life as we understand it. The discovery of exoplanets within this zone ignites our hopes for finding extraterrestrial life. Imagine distant worlds with vast oceans, breathable atmospheres, or even landscapes teeming with flora and fauna, waiting for us to uncover their secrets. Yet, the search for exoplanets goes beyond simply finding them. Understanding their atmospheres and surface conditions is crucial. To explore their habitability, scientists employ spectroscopy, analyzing the light that filters through a planet's atmosphere as it transits its star. This technique can reveal the presence of key molecules, such as oxygen, methane, or even carbon dioxide, hinting at possible biological processes. Each new piece of data adds a layer of complexity to our understanding of these distant realms, guiding us toward the tantalizing possibility of life. Moreover, the diversity of exoplanets is staggering. Some challenge our preconceived notions of what a planet can be. Super-Earths, for instance, are larger than Earth but smaller than gas giants, while hot Jupiters orbit perilously close to their stars, exhibiting extreme temperatures and atmospheric dynamics. This variety prompts us to rethink the conditions under which life might arise. Could life thrive in environments vastly different from our own? The more we learn, the more we realize that life's adaptability may exceed our wildest imaginations. As we expand our search into the realms of the unknown, the potential for discovering biosignatures, indicators of life, is both thrilling and daunting. The prospect of finding evidence of life elsewhere in the universe raises profound questions about our place in the cosmos. Are we alone, or do distant worlds harbor their own unique forms of life? Each exoplanet we study adds to this unfolding narrative, weaving a complex story of existence that challenges our understanding of biology, evolution, and the very nature of life itself. As we look to the future, the development of next-generation telescopes promises to revolutionize our quest. Instruments like the James Webb Space Telescope, which uses infrared technology to peer deeper into the universe, will allow us to observe exoplanets with unprecedented detail. This new perspective will enable scientists to analyze atmospheric compositions, search for signs of habitability, and perhaps even detect the elusive signatures of life. The universe may be more vibrant and teeming with life than we ever anticipated. The search for exoplanets also invites us to consider our own planet's fragility. As we explore the cosmos, it is essential to reflect on the delicate balance that sustains life on Earth. Our pursuit of knowledge must be accompanied by a sense of stewardship, recognizing that we are guardians of our home planet as we seek to understand our cosmic neighbors. The lessons learned from examining exoplanets could inform our understanding of climate change, environmental sustainability, and the intricate web of life that exists here. In our journey through the cosmos, we are not just searching for new worlds, we are seeking to understand ourselves. Each discovery brings us closer to answering fundamental questions: who are we? Where do we come from? And what awaits us among the stars? The exploration of exoplanets is a monumental endeavor, one that transcends boundaries and unites humanity in a shared quest for knowledge and discovery. As we continue to navigate the cosmic web, each exoplanet we identify ignites a spark of hope and inspires future generations to dream big. The possibility of finding life beyond our solar system is a reminder of the boundless wonders that await us in the universe. Each step we take in this search is a reflection of our collective curiosity and the enduring human spirit. The journey is far from over, and as we press forward, we carry with us the dreams of a brighter future, a future intertwined with the wonders of the cosmos. As we extend our reach beyond Earth, the dream of a multiplanetary civilization begins to take shape. Imagine a future where humanity not only survives but thrives across the celestial tapestry of our solar system. This vision sparks the imagination, but it also brings forth a complex array of challenges that we must confront. Each planet and moon presents its own unique environment, requiring innovative solutions and a deep understanding of extraterrestrial ecosystems. Mars stands as a prime candidate for our first off-world colonies. Its conditions are harsh, yet it has many similarities to Earth, such as a day length that's close to ours and the presence of water in the form of ice. Establishing habitats on Mars will involve creating self-sustaining ecosystems, capable of producing food and recycling waste. We must invent technologies to harness Martian resources, generating water from ice and extracting vital elements from the soil. Each colony serves as a testament to human ingenuity, a beacon of survival amid an alien landscape. Then there are the moons of Jupiter and Saturn, places like Europa and Titan that invite us to dream even bigger. Europa, with its icy shell concealing a vast ocean beneath, tantalizes us with the possibility of life. Establishing a colony here means not only overcoming the challenges of radiation and extreme cold but also developing methods to explore and perhaps even utilize the subsurface ocean. Titan, shrouded in thick clouds and boasting lakes of liquid methane, presents another frontier for human exploration. It requires us to rethink what life could be, to adapt to conditions that are utterly foreign, and to innovate in ways we have yet to fully imagine. The challenge of creating a multiplanetary civilization extends beyond the technical hurdles. It demands a shift in our perspective, nurturing a sense of stewardship for the worlds we visit. As we venture into these new realms, we must consider the ethical implications of colonization. How do we ensure that our presence does not disrupt potential ecosystems? How do we engage with the cosmic context of our actions, mindful of the fragility of life, both familiar and alien? Our exploration must be guided by respect and responsibility, recognizing that we are not merely conquerors of new worlds, but custodians of the universe's diverse environments. As we envision the infrastructure needed to support human life beyond Earth, we must also consider the psychological aspects of living in isolation. The vast distances between planets, combined with the confinement of spacecraft and habitats, can pose significant mental health challenges. Community, connectivity, and a sense of purpose will be essential to maintain the well-being of inhabitants on distant worlds. The fabric of society will need to adapt, embracing new forms of communication and cultural evolution. Amidst these considerations lies the great challenge of transportation. To link our burgeoning colonies, we must develop advanced propulsion systems that can traverse the solar system efficiently. Concepts like nuclear thermal propulsion or solar sails could enable us to make the journey feasible, but they require rigorous testing and development. The dream of interstellar travel, while tantalizing, is still on the horizon. For now, our focus remains on mastering the art of moving within our own solar neighborhood, where the lessons learned will pave the way for future endeavors. The vision of a multiplanetary civilization is not merely about survival, it is an opportunity to redefine what it means to be human. Our cultural and technological landscapes will be shaped by the knowledge we gain and the experiences we share across these new frontiers. Each colony could become a unique reflection of Earth's diverse cultures, merging traditional practices with new innovations born from the challenges of extraterrestrial life. This synthesis could enrich our collective identity, leading to an exciting era of collaboration and creativity. Furthermore, as we expand into the cosmos, we pave the way for scientific advancements that can transform life on Earth. the technologies developed for sustainable living on other planets, such as advanced recycling and renewable energy systems, will have applications here at home, helping to address climate change and resource scarcity. In this sense, our journey into the stars is not an escape from Earth but a return to our roots, bringing the knowledge we gain back to our home planet to foster its preservation. In imagining a multi-planetary future, we cannot overlook the potential for connection and collaboration with other civilizations, should we discover them. The universe may hold more than just the empty void, it may cradle intelligent life with whom we can share knowledge and experience. This perspective shifts the narrative from one of competition to one of unity, expanding our understanding of coexistence across the cosmos. As we chart the course toward becoming a multiplanetary species, we are reminded of the fragility and resilience inherent in life. Each step we take carries the weight of our history and the hope of our future. The journey ahead is filled with challenges, but it is also rich with possibilities. With every mission launched, every habitat constructed, and every human heart that beats in the depths of space, we weave ourselves into the vast fabric of the universe. The canvas is expansive, and our brush is poised, ready to paint a future that reflects not only our ingenuity but our aspiration for a harmonious existence among the stars. As we stand on the precipice of this cosmic frontier, the tools and technologies that will enable our journey into the deep unknown are advancing at an exhilarating pace. Robotics and artificial intelligence are transforming our capabilities, paving the way for an era where interstellar travel might shift from the realm of science fiction to a tangible reality. Imagine fleets of autonomous spacecraft equipped with sophisticated AI, capable of traversing the vast emptiness between stars, all while adapting to the myriad challenges that space presents. These robotic pioneers will not just be our emissaries but also our eyes and ears, gathering invaluable data from environments that are otherwise unreachable. The integration of AI into space exploration is a game changer. With its ability to process vast amounts of information in real time, AI can help navigate complex celestial terrains, make instantaneous decisions, and even manage life support systems on long-duration missions. This means that rather than relying solely on human oversight, we can deploy intelligent systems that learn and evolve, adapting to new conditions and unexpected challenges. Such capabilities are essential for interstellar voyages, where crewed missions could last decades or even centuries. Imagine a spacecraft that not only propels itself through the cosmos but also curates its own journey, optimizing routes and maintaining systems independently, allowing human crews to focus on exploration and discovery. In addition to autonomous systems, advancements in propulsion technology are also vital. One of the most promising avenues lies in the realm of nuclear propulsion, which harnesses the immense energy released during nuclear reactions. Nuclear thermal and nuclear electric propulsion systems could potentially cut travel time to Mars and beyond drastically, using less fuel than traditional chemical rockets. These innovations could enable us to reach distant planets in a fraction of the time, opening up our solar system for exploration and potential colonization. But even more ambitious are concepts like fusion propulsion. By mimicking the processes that power the stars, we could theoretically achieve efficiencies and speeds that make interstellar travel feasible within human lifetimes. Yet, the quest for faster-than-light travel has captivated our imaginations and inspired countless theories. Concepts like warp drives and wormholes, although still firmly in the realm of speculative physics, challenge our understanding of space and time. A warp drive could allow us to bend the fabric of spacetime, moving a spacecraft faster than light by creating a bubble of warped space around it. While this technology is still hypothetical, research into the fundamental laws of physics could uncover new pathways to making such dreams possible. Moreover, we must not overlook the role of materials science in the development of spacecraft. While traditional materials have served us well, the harsh environments of space require innovations that can withstand extreme temperatures, radiation, and micrometeorite impacts. Advanced materials, such as graphene and carbon nanotubes, promise not only enhanced durability but also significantly reduced weight. This improvement means more efficient designs, greater payload capacities, and ultimately, the ability to explore farther than we ever thought possible. As we envision our future in space, energy generation becomes a key consideration. Solar panels, which have powered satellites for decades, may not suffice for interstellar missions. Concepts like space-based solar power systems or even harnessing the energy of cosmic phenomena, such as pulsars, could provide the necessary fuel for long journeys. The potential to tap into dark energy remains a tantalizing mystery, hinting at sources of power that could revolutionize our approach to exploration and sustain life on distant worlds. Of course, as we push the boundaries of technology, we must also navigate the ethical implications that arise. The prospect of artificial intelligence piloting spacecraft raises questions about autonomy, decision-making, and the potential for unintended consequences. How do we ensure that these systems align with our values and safeguard human interests? As we design the future of exploration, we must engage with these ethical dilemmas and establish frameworks that will guide our actions beyond Earth. Robust communication systems will be essential as we extend our reach into the cosmos. Current radio technology limits the speed at which we can send and receive information across vast distances. Innovations in quantum communication could allow instantaneous information transfer, ensuring that our fleets of spacecraft remain in constant contact, regardless of the light years that separate them. This connectivity will be crucial for coordinating missions, sharing discoveries, and maintaining a sense of unity as we venture into uncharted territories. The foundation of our future in space will also rest on international collaboration. As we stand united in our quest for knowledge, pooling resources, expertise, and technology will amplify our efforts. The establishment of collaborative missions could enable us to tackle the immense challenges of cosmic exploration collectively, fostering a spirit of cooperation that transcends borders and cultures. As we continue to develop these technological innovations, the dream of interstellar travel becomes increasingly tangible. With every problem solved, every breakthrough achieved, we inch closer to a reality where humanity can blossom among the stars. The universe, with its endless wonders and mysteries, beckons us to explore its depths, and armed with ingenuity and determination, we are well on our way to answering that call. Our journey is not simply a quest for survival or expansion, it is a profound search for understanding and connection in the vast, mysterious tapestry of the cosmos. As we set our sights on interstellar travel, the role of artificial intelligence emerges as a pivotal force in our journey through the cosmic unknown. Imagine a spacecraft equipped with an advanced AI system, not just as a tool but as a crucial companion, capable of assisting in navigation, decision-making, and sustaining life during what could be years, or even decades, of travel beyond the confines of our solar system. AI would transform the way we approach the vast distances that separate us from the stars. Traditional navigation relies on a series of calculations and observations from Earth-based reference points, but in the emptiness of space, these markers fade away. Here, AI could process immense amounts of data in real time, analyzing cosmic phenomena, stellar movements, and gravitational fields to chart an optimal course. It would adapt to the unpredictable nature of the universe, recalibrating as new information becomes available, whether from unforeseen obstacles like asteroids or changes in solar activity from the star systems we traverse. But navigation is just the beginning. On a long-duration mission, the dynamics of life aboard a spacecraft become increasingly complex. AI would be instrumental in maintaining life support systems, continually monitoring and adjusting the atmospheric composition, temperature, and humidity to create a habitable environment. Imagine an intelligent system that learns from the subtle patterns of human behavior, predicting needs before they become urgent. This ability would support the crew's physical and psychological well-being, ensuring that food, water, and energy supplies are managed efficiently. Furthermore, AI could assist in decision-making when faced with critical challenges. Space exploration is fraught with uncertainties, and every decision can have profound consequences. With its capacity for analyzing vast datasets and simulating potential outcomes, AI could provide recommendations that enhance safety and mission success. It might suggest alternate routes that avoid hazardous regions or recommend adjustments to the ship's systems in response to anomalies. In these high-stakes scenarios, having a reliable, intelligent partner would be invaluable. As we delve deeper into the cosmos, the social dynamics of a crewed mission also come into play. Extended periods in isolation can strain relationships and test human endurance. Here, AI could serve as a mediator and companion, equipped with emotional intelligence algorithms to gauge the mood and mental health of the crew. It might engage with astronauts, offering conversation and support, helping to alleviate stress and loneliness. By fostering communication, AI could help maintain harmony among crew members, making the challenge of isolation a little more manageable. Looking into the future, as we expand our reach into the galaxy, the ability to adapt and learn will be essential. Imagine a spacecraft that not only completes its mission but also evolves throughout the journey. An AI system capable of machine learning could analyze successes and failures, refining its functions and improving its performance with each new challenge encountered. This adaptability could lead to innovations in space travel and exploration we have yet to dream of. The integration of AI into space missions also presents unique challenges that require careful consideration. The reliance on technology raises questions about autonomy and control. When should the AI take charge, and when should human judgment prevail? Finding the balance between human expertise and machine efficiency is crucial. Establishing protocols that define these boundaries will be vital, ensuring that astronauts can trust their AI companions while retaining the capacity to make critical decisions when needed. As we imagine future interstellar missions, the role of AI extends beyond navigation and life support. These intelligence systems could analyze extraterrestrial environments in real time, searching for signs of life or identifying resources that could sustain future human settlements. Equipped with advanced sensors and data processing capabilities, AI could continuously gather information about distant planets and moons, providing insights that inform our understanding of their potential for habitability. Moreover, the ethical implications of employing AI in space exploration cannot be overlooked. As we step into a realm where technology may operate autonomously, we must grapple with the moral responsibilities that accompany such power. Who is accountable for the actions of an AI? How do we ensure that our exploration of new worlds respects potential ecosystems? Considering these questions will be essential as we pave the way for a future where artificial intelligence plays an integral role in our cosmic endeavors. In this exciting frontier, AI serves not only as a facilitator of exploration but as a bridge connecting humanity with the cosmos. It helps us navigate the vast distances that separate us from our celestial neighbors, making the unfathomable journeys a bit more manageable. By enhancing our decision-making and supporting our well-being, AI empowers us to face the unknown without fear. The potential of artificial intelligence is not just to assist us, but to expand our understanding of the universe and ourselves as explorers. As we look ahead, one thing is clear: artificial intelligence will be our ally in navigating the complexities of the cosmos. With its ability to learn, adapt, and support us in ways we cannot yet fully comprehend, AI is paving the way for a future of exploration that promises to deepen our connection with the universe. The journey into the stars, supported by our most advanced technologies, invites us to embrace not just the vast unknown, but the incredible possibilities that await just beyond our reach. In this grand cosmic adventure, AI is not merely a tool. It is a vital partner in our quest for knowledge, understanding, and ultimately, our place in the universe. As we stand on the precipice of a new era in cosmic exploration, the excitement of venturing into the stars is tempered by a profound sense of responsibility. The ethical implications of exploring and potentially colonizing other worlds beckon us to reflect deeply on our actions and their consequences. With every mission, every spacecraft launched, we must grapple with questions that transcend science and technology, entering the realm of morality and philosophy. The allure of distant planets and unexplored moons captures our imagination, igniting dreams of human settlement beyond Earth. Yet, as we consider colonization, we must confront the potential ramifications of introducing our species to new ecosystems. What impact would humans have on pristine environments that have evolved over eons? The ecosystems we encounter may have delicate balances that our presence could easily disrupt. We have seen the consequences of our actions on Earth, where the introduction of non-native species and pollution has led to irreversible damage. Are we prepared to carry such a burden to other worlds? Furthermore, the concept of ownership in the cosmos raises its own set of ethical dilemmas. Space treaties currently advocate for the peaceful exploration of celestial bodies, emphasizing that no one nation can claim dominion over them. Yet, as private companies emerge as players in this cosmic frontier, the potential for exploitation grows. Will we repeat the mistakes of history, where the pursuit of fortune overrides the preservation of nature? The question looms large: how do we ensure that our quest for knowledge and resources does not come at the expense of the very worlds we seek to explore? In the context of colonization, we also face the moral consideration of existing life forms, however primitive they may be. What if we discover microbial life on Mars, or beneath the icy crust of Europa? The discovery of such life would challenge our views on stewardship and respect for other beings. Should we tread lightly, allowing these life forms to thrive, or do we risk their extinction in the name of human advancement? Our responsibilities extend beyond our own species. They encompass a commitment to safeguard the intricate web of life that may exist among the stars. Similarly, as we push the boundaries of our technological prowess, we must consider the implications of artificial intelligence in our exploration endeavors. The very AI systems designed to assist us on our journeys also carry their own ethical weight. How do we program them to make decisions in unforeseen circumstances? When faced with choices that involve potential harm to alien ecosystems or life, whose values will guide their actions? As we delegate more decision-making power to AI, we must ensure it aligns with an ethical framework that prioritizes respect for all forms of existence. The vastness of space presents another ethical challenge: the potential for interstellar conflict. As nations and private entities stake their claims in the cosmos, the competition for resources may escalate into territorial disputes. The ethical implications of such conflicts extend beyond the immediate threat of war. They raise questions about our ability to cooperate on a cosmic scale. Will we embrace the spirit of collaboration, or allow our ambitions to sow discord among those who share the universe with us? The prospect of conflict in space forces us to reconsider our approach to exploration and the values we wish to uphold as we venture forth. Additionally, the socio-political dimensions of space colonization cannot be ignored. The potential for creating new societies on other planets carries with it the risk of replicating Earth's inequalities and injustices. Who gets to inhabit these new worlds? Will the benefits of space exploration be accessible to all, or will they be confined to a privileged few? The vision of a multiplanetary civilization must be accompanied by a commitment to inclusivity and equity, ensuring that our cosmic future reflects the best of humanity, rather than its worst. As we ponder the ethical landscape of cosmic exploration, we are also reminded of the philosophical questions that arise. What does it mean to be human in the context of the universe? How do we define our responsibilities to other worlds and their inhabitants? These inquiries push us to reconsider our relationship with the cosmos, inviting us to view ourselves not as conquerors but as caretakers of a shared existence. In this profound journey into the unknown, we carry the weight of our history, our triumphs, and our failures. The legacies of colonization on Earth serve as cautionary tales, urging us to approach the stars with humility and respect. We have the opportunity to forge a new path, one that acknowledges the interconnectedness of all life and seeks to harmonize our presence with the cosmos. As we prepare for the unprecedented ventures that lie ahead, it is crucial to foster a dialogue about the ethical dimensions of our actions. Engaging diverse perspectives, including voices from philosophy, environmental science, and social justice, will enrich our understanding of what it means to embark on this cosmic odyssey. In doing so, we can create a framework for exploration that honors the complexity and beauty of the universe, ensuring that our journey into the stars is not only a testament to human ingenuity but also a reflection of our highest moral aspirations. In navigating the cosmic web, let us be guided by wonder, curiosity, and a commitment to ethical exploration. As we reach for the stars, we must remember that the journey is as much about our character as it is about our capabilities. Together, we can aspire to leave a legacy of wisdom and stewardship, paving the way for the generations that will follow in our footsteps across the galaxies. As we delve deeper into the cosmic web that binds galaxies together, we encounter a profound enigma: dark matter. This invisible substance, which makes up about 27% of the universe, is a silent architect, shaping the very structure of the cosmos in ways we are only beginning to understand. Though it cannot be seen and emits no light, its influence is undeniable, exerting gravitational forces that guide the formation and movement of galaxies. Picture the universe as a grand tapestry, intricately woven from the threads of visible matter, radiation, and the mysterious fabric of dark matter. Galaxies, like islands in an expansive ocean, are not simply scattered randomly throughout this vastness, rather, they are woven into a delicate structure governed by the gravitational pull of dark matter. Observations of galaxy clusters reveal that there is far more mass present than what we can account for with ordinary matter alone. The missing mass is attributed to dark matter, which acts as a scaffold, allowing galaxies to coalesce and cluster together. In the early universe, just moments after the Big Bang, the cosmos was a hot, dense soup of particles and radiation. As it expanded and cooled, ordinary matter began to clump together under the influence of gravity. However, without dark matter, these clumps would not have formed into the rich and diverse structures we observe today. Dark matter provided the necessary gravitational wells that allowed gas and stars to gather, coalesce, and ignite into the brilliant galaxies we see sprawling across the night sky. It is truly an unseen force, orchestrating a cosmic dance that gives rise to the stunning celestial landscapes. The significance of dark matter extends beyond mere structure, it influences the very dynamics of galaxies. When we look at a galaxy, we see the glowing stars and swirling gas, yet the majority of its mass is hidden from view. By studying how galaxies rotate, scientists have discovered that the stars at the edges of galaxies move at speeds that defy our understanding of gravity based solely on visible matter. This discrepancy leads us to conclude that a substantial amount of mass, untethered to any light, must be exerting its influence. This is dark matter at work. Furthermore, dark matter is not only foundational in shaping individual galaxies but also in forging the larger cosmic landscape. The cosmic web, a vast network of filaments and voids, is a testament to dark matter's role on a grand scale. Galaxies are not isolated entities, they are interconnected within this web, forming superclusters and larger structures that span millions of light-years. Dark matter acts like a glue, holding these vast cosmic structures together, creating the rich and complex universe we inhabit today. Recent advancements have allowed us to probe even deeper into the mysteries of dark matter. Experiments conducted deep underground or in remote locations aim to detect the elusive particles thought to make up dark matter. These efforts represent a monumental challenge, as the interaction between dark matter and ordinary matter is incredibly weak. Yet, the scientific community remains undeterred. Every experiment adds a thread to our increasingly intricate understanding of the universe. As we explore the implications of dark matter, we must also contemplate its potential future role in the ongoing evolution of the cosmos. The universe is not static, it is a dynamic entity, constantly evolving. The interplay between dark matter and dark energy, another mysterious force believed to be responsible for the accelerating expansion of the universe, raises exciting questions about the fate of all cosmic structures. Will dark energy ultimately overpower the gravitational attractions of dark matter, leading to a vast, empty universe? Or will the balance shift, allowing galaxies to coalesce into even larger structures over cosmic timescales? The exploration of dark matter also beckons us to reflect on our place within this grand cosmic narrative. As we seek to understand the unseen forces that shape our universe, we are reminded of the limits of our knowledge and the vastness of what remains to be discovered. Each new piece of evidence contributes to a more complete picture of the universe's history. It's a journey that challenges our perceptions of reality and our definitions of existence itself. In contemplating the significance of dark matter, we find ourselves at the intersection of science and wonder. It prompts us to ask profound questions about the nature of the universe. How did it come to be? What lies beyond the reach of our current understanding? As we continue our quest for knowledge, we become aware that we are not just passive observers of the cosmos, we are active participants in an ongoing exploration, driven by curiosity and the desire to comprehend the mysteries that surround us. With the knowledge of dark matter's essential role in the universe, we can imagine a future where our understanding transcends the limits of current technology. The ongoing quest for interstellar travel may one day lead us to harness the very forces that dark matter represents. Could we unlock the secrets of the universe's architecture and use it to traverse the vast distances that separate us from other worlds? The possibilities are tantalizing, fueling our aspirations to explore not just the stars, but the deeper questions of existence itself. As we ponder the vastness of space and time, we come to appreciate that dark matter is not merely an abstract concept, it is a fundamental part of our cosmic story, inviting us to delve deeper and explore the profound connections that bind the universe together. In the pursuit of this knowledge, we cultivate a greater appreciation for the intricacies of the cosmos, nurturing a sense of wonder that propels us forward into the uncharted territories of our future. As we continue to navigate the vast cosmic web, we encounter an incredible remnant of our universe's infancy, the cosmic microwave background, often referred to as the CMB. This faint afterglow of the Big Bang is not merely a relic, it is a treasure trove of information, holding the key to understanding the very fabric of our existence. Imagine standing in a dark room, and with a flick of a switch, the faintest light illuminates the shadows. This light, a whisper from the past, offers us a window into the chaotic moments that unfolded nearly 14 billion years ago. The CMB is a nearly uniform sea of microwave radiation that fills the universe, a subtle echo of the hot, dense state from which it emerged. Approximately 380,000 years after the Big Bang, the universe had cooled enough for electrons and protons to combine and form hydrogen atoms. This moment, known as recombination, allowed photons to travel freely through space for the first time, releasing the light we now detect as the CMB. It is this ancient light that reveals the universe's early conditions, showing us a time when the cosmos was still forming, like a painter beginning to lay down the first strokes of a grand masterpiece. What makes the CMB so captivating is not just its origin, but the information it carries. Fluctuations in temperature and density are imprinted within this cosmic radiation, providing vital clues about the universe's composition, its expansion, and the distribution of matter. These tiny variations, only a few microkelvins above or below the average temperature, correspond to the seeds of all the galaxies and structures that would eventually emerge. Analyzing these fluctuations reveals the universe's overall geometry and fate, guiding our understanding of how galaxies formed and evolved over billions of years. Among the secrets encoded in the CMB is the elusive presence of dark matter. While we cannot see dark matter directly, its gravitational effects on visible matter help us infer its existence. The fluctuations in the CMB reflect the density variations of both visible and dark matter in the early universe. This connection is profound. It reinforces the idea that dark matter is not an isolated mystery but is intricately woven into the fabric of cosmic evolution. It acts as the scaffolding around which galaxies built themselves, shaping the connections we observe today. As we analyze the CMB, we uncover a tapestry of structure and order in what might otherwise seem like a chaotic universe. The patterns we see are not random, they are a result of the physics governing the early universe. This gives scientists invaluable insights into the fundamental forces that shaped our cosmos. The interplay of gravity and radiation dynamics during those early moments, before stars and galaxies took form, reveals how these primordial conditions set the stage for everything that followed. The CMB also raises fascinating questions about the very nature of the universe. For instance, the precise measurements of the CMB have provided strong evidence for the theory of inflation, a rapid expansion of space that occurred just after the Big Bang. This theory suggests that the universe underwent an exponential growth spurt in its earliest moments, smoothing out irregularities and setting the stage for the large-scale structure we observe today. This idea challenges our intuitive understanding of how the universe evolves and hints at the complexities of its origins. Moreover, the CMB serves as a cosmic time capsule, preserving a snapshot of the universe at an age just shy of 400,000 years. Every observation of this ancient light enriches our understanding of cosmic history. Projects like the Wilkinson Microwave Anisotropy Probe and the Planck satellite have painstakingly mapped the CMB, allowing us to refine our models and assumptions about the universe's composition. Through this meticulous work, we gain confidence in our estimates of the amounts of dark energy and dark matter relative to normal matter. As we delve deeper into the CMB, we are confronted with the increasingly intricate fabric of cosmic existence. The discoveries derived from studying this primordial radiation not only inform us about the universe's early state but also guide us towards understanding its ultimate fate. With each passing day, as technology advances, our ability to probe this cosmic relic improves, revealing more about the enigmatic forces that shape the universe. Yet, the CMB does more than provide insight into the past, it fuels our imagination about the future. As we learn more about the universe's expansion and the role of dark energy, we find ourselves pondering the long-term fate of our cosmos. Will it continue to expand forever, or will gravitational forces eventually conspire to bring it all back together? The answers lie in the cosmic echoes of the past, in the silent whispers of the CMB. As we stand on the brink of new discoveries, we are reminded that the journey of understanding is ongoing. The cosmic microwave background not only connects us to our origins but also challenges us to peer into the deepest mysteries of existence. It invites us to explore a universe that is far more complex, dynamic, and interconnected than we could ever have imagined. In doing so, we cultivate a profound appreciation for the cosmos, igniting our curiosity and propelling us ever forward into the vast expanse of the unknown. As we venture deeper into the cosmic landscape, a tantalizing horizon emerges, the potential to harness dark energy, the enigmatic force driving the accelerated expansion of the universe. Imagine a future where humanity taps into this elusive energy source, not just as a means of understanding the cosmos but as a transformative power for space travel and exploration. This concept may seem like pure science fiction, yet the implications of such technology could redefine our existence among the stars. In essence, dark energy composes about 70% of the universe, a vast reservoir of energy that remains shrouded in mystery. This invisible force acts against gravity, pushing galaxies apart and shaping the universe's fate. If we could decipher its mysteries and unravel the science behind it, we could potentially unlock a new frontier in energy production, one that promises to be as limitless as the universe itself. Imagine spacecraft powered not by traditional fuels but by the very fabric of the cosmos, utilizing dark energy as a propulsion mechanism, allowing humanity to traverse vast distances across the galaxy with unprecedented efficiency. One speculative approach to harnessing dark energy could involve advanced technologies that manipulate spacetime. Drawing upon the principles of general relativity, scientists theorize that it might be possible to create a device that generates a localized region of negative energy density. This would allow us to create what is often referred to as a warp bubble, a space where the laws of physics bend to our will, enabling faster-than-light travel. Such a machine would not move through space in the conventional sense; instead, it would warp the space around it, contracting distances in front while expanding them behind. This profound alteration of spacetime could take humanity to distant star systems within a matter of days or weeks rather than years. The engineering challenges associated with such technologies are monumental. Developing materials that can withstand the incredible stresses involved in manipulating spacetime would require breakthroughs in materials science and quantum physics. Yet, the pursuit of these technologies could ignite a cascade of innovations, ushering in an era of exploration that pushes the boundaries of what we envision as possible. We might find ourselves at the forefront of a new technological renaissance, where the quest for understanding dark energy catalyzes developments that enhance our lives on Earth as well. Another conceivable approach involves the direct extraction of dark energy's effects through advanced quantum technologies. In quantum field theory, dark energy is thought to arise from the vacuum of space itself, a sea of fluctuating energy that underlies all reality. If we could find a way to manipulate these quantum fluctuations, we might be able to create a steady energy output that could be harnessed for propulsion systems or other advanced technologies. This would not only provide energy for interstellar travel but would also serve as an invaluable resource for sustaining life on distant planets and moons, allowing human civilization to flourish beyond Earth. Furthermore, we may also find inspiration in the fusion of artificial intelligence with these emerging technologies. As we strive to build machines capable of navigating the complexities of dark energy, AI could play a pivotal role in simulating and optimizing these processes. With the ability to analyze vast datasets and predict outcomes, artificial intelligence could help humanity unlock the secrets of dark energy more rapidly than ever before. This partnership between human ingenuity and intelligent systems could accelerate our advancements, leading to remarkable breakthroughs in energy harnessing and propulsion systems. In exploring these possibilities, it is essential to acknowledge the ethical considerations and responsibilities that come with wielding such powerful technologies. Harnessing dark energy could offer incredible benefits, but it also poses risks that must be carefully managed. The potential for misuse or catastrophic consequences looms large, and as we delve into the unknown, we must ensure that we are guided by a strong moral compass. Our exploration of the cosmos must be tempered by a commitment to safeguard our planet and the delicate balance of life it harbors. As we persist in our quest to understand dark energy, we should also reflect on its broader implications for our place in the universe. If we succeed in harnessing this energy, it could serve as a tangible manifestation of humanity's ingenuity, a testament to our relentless spirit of exploration and discovery. It would signify not just our ability to unlock the universe's secrets but our readiness to embrace the responsibilities that come with such power. The allure of dark energy is not merely in its potential as a power source but in the profound questions it raises about existence itself. What does it mean to harness the very forces that govern the cosmos? How does our understanding of dark energy reshape our perspective on life, the universe, and everything in between? These reflections can guide us as we forge ahead, illuminating our path as we gaze into the cosmos, driven by an insatiable curiosity and a desire to understand our place within it. In this grand exploration, we stand at the precipice of a new era, one where the mysteries of dark energy beckon us forward. With each step into the unknown, we not only seek to harness the power of the cosmos but also to illuminate the very essence of who we are as explorers, innovators, and dreamers. The journey of unraveling dark energy is just beginning, and its potential to transform our future is a challenge we must embrace with open minds and hearts. As we continue to push the boundaries of scientific discovery, we embark on a path that could lead to unimaginable horizons, forever altering our understanding of the universe and our place within it. As we stand on the precipice of this grand cosmic adventure, it is vital to acknowledge that the path ahead will not be a straight line filled with predictable milestones. The universe is a realm of uncertainties, teeming with mysteries that have yet to be unveiled. Each step into the vastness invites unexpected challenges and revelations. This is not merely an exploration of distant planets and stars but a deep dive into the very fabric of reality itself, where we must prepare for the unknown. In our pursuit of knowledge, we resemble explorers of old, setting sail into uncharted waters. Just as those early mariners grappled with storms and navigated by the stars, we too must hone our skills, adapt our technologies, and cultivate a mindset ready to embrace the unexpected. Imagine the first astronomers peering through their telescopes, their hearts racing at the sight of celestial bodies they had only theorized about. They encountered not just beauty, but also anomalies, strange patterns in the night sky that sparked debates and ignited curiosity. This spirit of curiosity must be our guiding star as we venture into the depths of space. The cosmos is full of enigmas, from the sudden flicker of a distant supernova to the eerie silence of vast regions where no light dares to tread. With each discovery, new questions arise, demanding our attention and ingenuity. We are already witnessing this in our studies of dark matter and dark energy, where the answers elude us, wrapped in a veil of mystery. These are the challenges that stretch our scientific understanding and compel us to rethink fundamental principles. Each hurdle presents an opportunity to innovate, to expand our horizons, and to redefine what we consider possible. As we dream of interstellar travel, we must grapple with not only the technical hurdles but also the psychological and sociological dynamics that come with journeying beyond our solar system. The vast distances involved in space travel mean that any expedition could take years, if not centuries. The isolation and confinement of crew members aboard spacecraft could lead to unforeseen psychological stresses. Preparing for these unknowns includes not just engineering solutions but also fostering resilience, camaraderie, and adaptability among those brave enough to shoulder the mantle of exploration. Moreover, we cannot overlook the ethical dimensions of our cosmic endeavors. As we prepare for the unknown, we must grapple with not only the potential for discovery but also the responsibilities that accompany it. What does it mean to reach out to new worlds, possibly harboring life? How do we ensure that our search for knowledge does not disrupt ecosystems we are yet to comprehend? These are profound questions that require thoughtful reflection and the foresight to navigate moral dilemmas as we explore. In facing the unknown, we must also embrace the role of technology as both a tool and a catalyst. Advancements in artificial intelligence hold the promise of enhancing our capabilities in navigation, data analysis, and even decision-making during missions that push the boundaries of human endurance. Imagine AI systems capable of processing vast amounts of astronomical data in real time, identifying potential hazards, or even suggesting modifications to our approach based on evolving conditions. The synergy between human intuition and artificial intelligence could prove vital in preparing for the myriad challenges of space exploration. Yet, the most profound preparation lies in the very act of questioning our assumptions. History has shown that the universe often operates beyond the confines of our current understanding. As we turn our gaze towards the stars, we must be ready to encounter phenomena that challenge our deepest beliefs about physics, biology, and the nature of existence itself. The notion of wormholes, for instance, suggests a radical rethinking of spacetime, while the behavior of black holes continues to baffle even the brightest minds in astrophysics. With every revelation, we inch closer to a more complete picture, one that may ultimately shift our perspective on life, our universe, and our role within it. Preparing for the unknown also means fostering a culture of adaptability within the scientific community. The most significant breakthroughs often arise from unexpected avenues. Embracing a diversity of thought, allowing room for unconventional ideas, and encouraging interdisciplinary collaboration can lead to innovations that we cannot yet predict. The more we cultivate an environment where curiosity reigns and where failure is seen as a stepping stone rather than a setback, the better equipped we will be to tackle the unexpected challenges we encounter along the way. As we venture forward, let us remember that the story of humanity is one of resilience and discovery. Every leap we take into the unknown is a testament to our innate curiosity and our desire to understand the cosmos. In this grand narrative, each challenge we face becomes a brushstroke on the expansive canvas of human achievement. With each mission, each probe sent into the void, and each telescope aimed toward the farthest reaches of space, we prepare not just for what we hope to find, but for what we may never have imagined. The journey through the cosmos will be fraught with uncertainties, but it is precisely these uncertainties that make it all the more exhilarating. So let us embrace this voyage into the unknown with open minds and courageous hearts, ready to uncover the mysteries that lie beyond the horizon of human understanding. The universe awaits, with secrets and stories yet untold, beckoning us to unravel its wonders and, in the process, discover our own place in the grand tapestry of existence. As we stand on the precipice of discovery, it's vital to pause and reflect on our place within this vast cosmic theater. Each of us is a thread woven into the intricate fabric of existence, an essential part of a grand narrative that stretches from the smallest subatomic particles to the sprawling galaxies that swirl in the inky blackness of space. The universe, with its majestic complexity, reveals an interconnectedness that is both humbling and awe-inspiring. We are not merely observers of this celestial dance, we are participants, linked to every atom in our bodies that has originated in the hearts of stars long extinguished. Consider for a moment the atoms that compose your very being. They were formed in the fiery furnaces of ancient stars, scattered across the cosmos when those stars met their fiery end. These elements found their way to Earth, giving rise to the life we know today. This profound unity with the universe serves as a reminder of our shared heritage and the cycles of creation and destruction that govern existence. The air we breathe, the water we drink, and the very ground beneath our feet are all manifestations of cosmic processes that have unfolded over billions of years. In this light, we are not isolated entities but rather expressions of the universe itself, animated by the same fundamental forces that shape galaxies and forge the very structure of spacetime. As we delve deeper into the mysteries of dark matter, black holes, and the potential for interstellar travel, we begin to grasp the enormity of our quest. Each scientific breakthrough, every new discovery, serves to illuminate our understanding of the cosmos and, in turn, our role within it. When we explore the nature of black holes, for instance, we are not just studying enigmatic objects, we are probing the limits of our understanding, challenging our perceptions of time and reality. Black holes remind us that the universe can be both beautiful and terrifying, a place where the known collides with the unknown, urging us to confront the mysteries that lie at the fringes of our comprehension. In contemplating these cosmic phenomena, we also find ourselves drawn to the question of our future. The allure of interstellar travel ignites our imaginations, prompting us to dream of distant worlds where life might flourish and new civilizations could be born. As we consider the possibility of becoming a multiplanetary species, we must ask ourselves how we will navigate this vastness, how we will ensure that our explorations are guided by wisdom and compassion. The stars beckon us not just as explorers, but as stewards of the universe. Our understanding of ethics in cosmic exploration is paramount. We carry the responsibility of preserving the beauty and integrity of the worlds we encounter. The concept of dark matter, which constitutes a staggering portion of the universe's mass yet remains elusive to our instruments, challenges us to refine our understanding of reality. It serves as a profound symbol of the mysteries that still lie ahead, urging us to remain curious and humble. We must approach our inquiries with respect and reverence for the unknown, for every piece of knowledge we unveil only leads to more questions, expanding the horizon of our curiosity. This journey into the depths of the cosmos is more than an intellectual pursuit, it is a deep exploration of our connection to the universe and to one another. As we endeavor to unlock the secrets of dark energy and harness its potential, we stand at the convergence of science and imagination. The technologies we develop today will shape the path for generations to come. Every innovation, every leap in understanding, is a step toward a future where we might traverse the stars, bridging the gaps between worlds. Yet, as we dream of what lies beyond, we must also be vigilant stewards of our own planet. The interconnectedness of all things is a call to action, urging us to care for our home while we extend our reach into the cosmos. In this cosmic perspective, we are reminded of the beauty of collaboration. Scientists, researchers, and thinkers from around the globe unite to push the boundaries of knowledge, pooling their insights and expertise to explore the mysteries that bind us. This collaboration reflects the essence of humanity, collectively striving for a brighter future, driven by the same curiosity that propels us to gaze upwards at the stars. It inspires us to forge connections, to share knowledge across cultures and disciplines, and to recognize that our destinies are intertwined. As we look to the night sky, we are reminded that we are part of something much greater than ourselves. Each twinkle of a distant star is a reminder of our shared existence, urging us to find meaning in our journey. The universe invites us to dream, to question, and to explore, embracing the uncertainties that accompany discovery. With this cosmic perspective, we are empowered to navigate the challenges that lie ahead with resilience and hope. In the end, our exploration of the cosmos is not merely about seeking new worlds or understanding the fundamental laws of nature, it is about discovering the essence of what it means to be human. It is about recognizing our place in the universe as both caretakers and adventurers, driven by the insatiable desire to learn and grow. As we venture forward into the great unknown, may we carry with us the understanding that we are all part of a magnificent cosmic tapestry, woven together by the forces of creation and interconnectedness. The journey continues, and with it, the promise of wonder awaits. As we stand on the precipice of exploration, gazing up at the stars, we are compelled to consider the legacy we will leave behind. Each mission, each discovery in the vast expanse of space is not merely an act of curiosity, it is a deliberate step in the unfolding story of humanity. Our efforts in space exploration are shaping not just our understanding of the universe, but also the very essence of what it means to be human. The challenges we face in our quest for knowledge are monumental, yet they bring forth opportunities for growth, innovation, and unity. Imagine future generations reflecting on this era of discovery. They will see it as a time when humanity dared to reach beyond its fragile home planet, propelled by a shared dream. The technology we develop today, from advanced propulsion systems to new materials designed for the rigors of space, will lay the foundation for the civilizations of tomorrow. Our innovations will echo through the ages, inspiring countless individuals to look up at the night sky with wonder and ambition. As we unlock the secrets of dark matter and black holes, we illuminate the path for future explorers, revealing not just the mechanics of the cosmos, but the profound connections that bind us all. The legacy of our exploration will extend beyond the scientific realm. It will touch the very fabric of our societies, influencing our philosophies, our cultures, and our values. As we venture further into the cosmos, we confront questions that challenge our perceptions of existence. What does it mean to be part of a multiplanetary civilization? How do we define life when we encounter worlds that may harbor forms of existence beyond our understanding? Each new discovery forces us to re-evaluate our place in the universe, urging us to consider our responsibilities not only to ourselves but also to any potential life we may find among the stars. In this ambitious endeavor, collaboration will be key. The exploration of space is not solely the domain of one nation or one group of people. It requires a collective effort, pooling the expertise and insights of scientists, engineers, and dreamers from all corners of the globe. Through this unified approach, we can cultivate a sense of shared destiny, reminding us that, despite our differences, we are all inhabitants of the same fragile blue planet, embarking together on a journey through the cosmos. In forging international partnerships, we not only accelerate our advancements but also foster peace and understanding among nations, creating a legacy of cooperation that transcends borders. Yet, with each leap forward, we must tread thoughtfully. The ethical implications of our explorations will shape the narrative of our legacy. As we develop technologies capable of interstellar travel, we must grapple with the moral responsibilities that accompany such power. How do we ensure that our pursuit of knowledge does not come at the expense of other worlds? The lessons from our own planet's history urge us to consider the impact we have on environments beyond our own. The legacy we leave behind should reflect a commitment to stewardship, an understanding that exploration is not merely about conquest, but about coexistence and respect for the unknown. As we explore the cosmos, we are also invited to reflect on what it means to be human. The vastness of space can be both humbling and empowering. It reminds us of our fragility and our resilience. The challenges we face advancing our technology, understanding the mysteries of dark energy, and ensuring our survival are not just scientific problems, they are opportunities to redefine our character as a species. Our legacy will be one of innovation born from adversity, showcasing our ability to adapt and thrive in the face of the unknown. In reflecting on the legacy of our exploration, we must also remember that it is not solely about the grand missions to distant planets or the search for extraterrestrial life. The legacy is woven into the fabric of everyday life, influencing how we see ourselves and our place in the universe. Each small discovery in our understanding of the cosmos enhances our appreciation for the intricate dance of galaxies and the delicate balance of life on Earth. The technologies we create for space travel often find their way back to improve life here at home, from advancements in communication to innovations in medicine and environmental sustainability. As we envision our legacy, we must fill it with hope and a sense of purpose. The journey into the cosmos is not just a quest for knowledge, it is an opportunity to unify humanity around a common goal. It is a chance to foster a global perspective, where the challenges of our time, climate change, resource scarcity, and social inequality, are addressed with the same ingenuity and determination we apply to our explorations of space. The legacy we carve out today can ignite a flame of passion for discovery that will burn brightly in the hearts of future generations, inspiring them to look beyond the horizon and continue the voyage we have begun. Ultimately, the legacy of our exploration will be one of interconnectedness, creativity, and a profound reverence for the cosmos. It will be defined not just by the stars we reach but by the wisdom we gather along the way. As we continue this extraordinary journey into the unknown, let us commit ourselves to a future where our legacy is one of enlightenment, compassion, and an unwavering desire to understand the universe that cradles us. The stars may seem distant, but together, we can illuminate the path that leads us ever onward, into the vast expanse of possibility that awaits us in the great beyond. As we stand at the precipice of understanding, gazing into the boundless expanse of the cosmos, we find ourselves intertwined with mysteries that beckon us forward. The journey we have embarked upon, from unraveling the enigma of dark matter to contemplating the vastness of black holes, has revealed a universe both intricate and awe-inspiring. We have navigated the cosmic web, discovering the dance of galaxies and the silent hand of gravity that weaves them together in a grand tapestry of existence. In this exploration, we have uncovered the profound depth of black holes, those enigmatic regions of spacetime that challenge our very understanding of physics. They are not mere voids but rather gateways to questions that stretch the limits of human knowledge. The nature of singularities and event horizons pushes us to confront the boundaries of scientific inquiry, urging us to seek answers to questions that have lingered for centuries. What lies beyond the event horizon? Can we truly comprehend the inexplicable? These questions invite us not only to explore the cosmos but to embrace the unknown as part of our journey. The cosmic dance of galaxies reveals the interconnectedness of all things, reminding us that we are not mere spectators in this grand performance, but active participants in the unfolding narrative of the universe. Each star, each planet, and each flicker of light carries a story, a history that has shaped the cosmos and, in turn, shapes us. As we peer into the depths of space, we are reminded that the wonders we seek are not only external but also deeply intrinsic to our human experience. The potential for future interstellar travel ignites our imagination, as we dream of crossing the vast distances that separate us from other worlds. The concept of wormholes as bridges in spacetime tantalizes our minds, leading us to envision a future where the seemingly impossible becomes a reality. The quest for faster-than-light travel drives our scientific spirit, challenging us to innovate and push the boundaries of what we know. As we delve into the physics of propulsion, we are reminded that our thirst for knowledge is the very fuel that propels us into the unknown. Yet, with every leap forward, we face the formidable challenge of cosmic distances. The vast emptiness of space can be daunting, but it is also a canvas for human ingenuity. The search for exoplanets has already begun to yield exciting discoveries, revealing worlds that may harbor the conditions for life. Imagining a multiplanetary civilization is not just a dream, it is a possibility that ignites our aspirations and compels us to look beyond Earth as we seek our place in the universe. Technological innovations are the cornerstone of our journey, shaping the tools we use to explore. From advanced propulsion systems to artificial intelligence, our creations will be essential as we traverse the stars. AI holds great promise in assisting us with navigation, data analysis, and even the ethical considerations of our exploration. As we stand on the brink of this new frontier, we must also ponder the ethical implications of our cosmic endeavors. The responsibility of exploration weighs heavily on our shoulders, urging us to proceed with caution and respect for the worlds we seek to understand. Dark matter, the unseen architect of the universe, reminds us of the complexities that lie beyond our perception. It shapes galaxies and influences the very structure of the cosmos, yet it eludes our direct observation. As we strive to harness dark energy and unlock the secrets of the universe, we also embrace the notion that some mysteries may never be fully understood. It is in this quest for knowledge that we find the essence of discovery, a journey that brings us closer to the cosmos, while simultaneously revealing the limitations of our understanding. As we contemplate the cosmic microwave background, we are reminded of the echoes of the Big Bang, whispers from the dawn of time that connect us to our origins. Each discovery propels us further into the vastness, illuminating the path toward future technologies that may one day transform our understanding of space and time. The journey ahead is not merely about reaching new frontiers, it is about fostering a sense of unity and purpose in our exploration, as we prepare for the unknown that lies ahead. Ultimately, the cosmic perspective invites us to see ourselves as part of something larger, a grand narrative that spans the ages and unites all forms of existence. As we reflect on our legacy, we must remember that our exploration is not just for ourselves but for generations yet to come. Let us strive to leave a world that values enlightenment, compassion, and curiosity, where the thirst for knowledge drives progress and nurtures our collective spirit. The stars may seem distant, but they call to us with a promise of discovery, urging us to step boldly into the future. So, let us embark on this journey together, with hearts filled with wonder and minds eager to explore. As we navigate the cosmic web, we carry with us the wisdom of the past and the hope of a brighter tomorrow. The universe awaits an ever-expanding frontier, rich with possibilities, ready to reveal its secrets to those who dare to reach for the stars.